Nice.
Good morning, sir.
Good morning, madam.
Good morning, madam.
Sir, how are you?
Fine, madam.
Good morning, sir, and a hearty welcome to the university, sir.
Good morning, sir.
Good morning, good morning,
Good morning, sir.
good morning. Good morning, sir.
Good morning, sir.
Sir, good morning, sir. Srinath, sir.
Yeah, good morning. Good morning, young man.
Good morning. Good morning.
Good morning, madam.
Good morning, sir.
Oh, good morning, Andy.
And good morning,
Good morning,
sir.
sir.
Good morning, good morning, good morning.
Sir, good morning, sir. Good morning.
Oh, good morning, Andy.
Sir, good morning, sir.
Good morning, good morning. Let us start the program.
Okay, sir. Good morning, everyone. I am Nukaratnam, head of the Department of Geology, Adikavi Nannaya University, and convener of the today's webinar. It's my great privilege to welcome Honorable Vice Chancellor of the University, Professor Makka Jagannath Rao sir, and Regional Director Sri G. Krishnamurthy sir from Central Groundwater Department, and today's speakers, Dr. VSR Krishna, scientist, Carolyn Lewis, scientist, and Sri G. Ravikumar, scientist from Central Groundwater Department, Ministry of Jal Shakti, Government of India. I also welcome respected Registrar Professor T. Ashok sir and Dr. K. Ramaneshwari, Principal, EC member of the University, Professor K. S. Ramesh sir, and also Dr. B. Jaganmohan Reddy sir, and deans, directors, and other officers of the university. I also welcome Professor Venkatesh Rao sir, retired professor and expert in groundwater, my co-faculty members, research scholars, students, and all other participants who are present over here. A warm welcome to you all for today's webinar on public interaction program on aquifer mapping and management in Andhra Pradesh State Board, with special emphasis on East Godavari district, being organized by Department of Geology and Central Groundwater Department, Southern Region, Hyderabad. Groundwater, which is an aquifer below the surface of the earth, is one of the most important natural resources and is essential for sustenance of human life. The quality of groundwater can be improved through dilution when recharged. This webinar is intended to create awareness about the groundwater resources, modeling, management, and mapping techniques. I'm sure that the insights and views by the experts in this webinar would be immense help and all the participants for conserving the process precious gift that is water. I believe the deliberations would certainly benefit the students and research scholars in terms of adopting the strategies of water resource management, especially groundwater. And I'm happy that we have got a very good response from the academia and scientific community for participation in this program. The registration link will be sent through chat box. All the participants are requested to fill the registration link. So now, with these few words, I now request Shri Ravikumar sir, scientist from Central Groundwater Department, to take over the session and proceed further. Over to Ravikumar sir.
Thank you, madam. Thank you very much. Honorable, respected Professor Mokka Jagannatha Rao sir, Vice Chancellor, Adikavinana University, and Nukaratnam Garu, Head of the Department Geology, Adikavinana University, and other dignitaries and students and research scholars. Welcome to this public interaction program. As Madam has said about the various nuances of why this public interaction, we take this forward, inviting Sri G. Krishnamurthy Garu, Regional Director in charge, Central Groundwater Board, Southern Region, Hyderabad, to address the participants. Before requesting G. Krishnamurthy sir, I would like to go through about his brief biodata. G. Krishnamurthy Garu obtained his master's degree in KV University, Karnataka in the year 1993. He joined Central Groundwater Board in the year 1997. Before, he had served 4 years of his service in Geological Survey of India. He joined and worked in Southeast Coastal Region, Chennai, in Central Groundwater Board from 1997 to 2004, and later at Southwestern Region, Bangalore, from 2004 to 2018. Now he was posted at Hyderabad and is currently discharging his duties as regional director in charge. He has a vast experience in the field of geophysics and subsurface hydrogeology of hard rock, particularly of hard rock aquifer systems of Karnataka, Tamil Nadu, Andhra Pradesh, and Telangana. With these few words, I request Sri G. Krishnamurthy sir to say the welcome to address the participants and of this program today. Thank you, sir.
Thank you, Ravi. Thank you very much. And I welcome today's all participant today's PIP program. Central Groundwater Board is conducting public interaction program to commemorate the 75 years of India's independence. Sri Narendra Modi Garu, Honorable our Prime Minister of India, had given the call to the nation to celebrate the 75 years of independence to reflect the work that have been done so far, various fields of science and technology, development, policy, and various others. It is like wherever we come together and share our success stories to step forward to build the nation and take it forward to leap and bound manner. Here, CGWB, we have a legacy of 50 years of service in serving the nation through our activities of groundwater exploration, exploring the various aquifers, finding out their disposition, yield, quality, etc. through reappraisal and district groundwater management studies. We have covered and surveyed entire India and achieved our findings. CGWB, along with the states of erstwhile Andhra Pradesh and Telangana, have been doing groundwater resources assessment state-wise from 1997 and 2020, and groundwater resources in terms of availability, draft, future, allocation, and categorization of mandals. Under National Aquifer Mapping and Management done for the Andhra Pradesh state of Anantapur, Chittoor, Visakhapatnam, parts of Prakasham, East and West Godavari, Krishna districts, covering about 75,000 square kilometer out of 1,62,000 square kilometer, we have put together of completion as by 2023 for entire AP under NACIM program. Today, we are here to share the aspects of those studies and success stories. The PIP presentations are divided taking into consideration of students, research scholars, so that fundamental aspects of hydrogeology, its applications in aquifer mapping and management. Hope this PIP program is beneficial. Top you all. Thank you. Thank you, one and all. And I will hand it over to Ravi Kumar Garu for further proceedings. Thank you once again to all.
Thank you very much, sir, for the brief introduction about the public interaction program. Now, we are very privileged to be with us, Professor Mokka Jagannatha Rao, sir, Honorable Vice Chancellor, Adikavi Nanne University. He has a vast experience, both academically and in terms of management aspects also. I would like to give a brief profile of Professor Mokka Jagannatha Rao, sir, on this occasion. Professor Mokka Jagannatha Rao, sir, Honorable Vice Chancellor of Adikavi Nanne University, Rajamahendrapuram, has done his education both in India and abroad. He got his master's degree in engineering from University of Alaska, United States of America. He got his PhD from Andhra University, Visakhapatnam in the year 1985. He joined as assistant professor in the Department of Geology, Andhra University in 1986, and later promoted to professor and head of the department of the same department. He is a serious researcher and academician, having more than 33 years of experience in both teaching and research. He has published nearly 150 research papers in national and international journals. 33 scholars got awarded PhDs under his able guidance. His students are not only from geology, but also from computer sciences, geoengineering, geophysics, and allied physics. He has a strong research collaboration with various organizations from USA, Canada, and Australia. He had completed 8 funded projects from leading funding agencies of this country, including Department of Science and Technology, University Grant Commission, CSIR, DOD, APMDC, DMR, UF, MOES, ISRO, and ONGC. He got huge consultancy projects from ONGC, like studies on Holocene evolution in Mahanadi Delta, studies on land subsidence due to hydrocarbon exploration and exploitation of PG and PG basin Andhra Pradesh using remote sensing and field studies. He has a vast experience in administration too. He held various administrative positions like Director of Information and Management Center, Andhra University, Visakhapatnam, Andhra Pradesh, and Dean of PG and Professional Examination, Andhra University, Director of International Studies Affairs, Andhra University, Director for Delta Studies Institute, Andhra University, Chairman for Board of Studies, Department of Geosciences, Ambedkar University, Srikakulam, Andhra Pradesh, and Head of the Department, Department of Geology, Andhra University, and many others. He had filed a patent entitled an inventive model that explains the genesis of Bay of Bengal and Arabian Sea, which is under consideration. He got many awards and honors, including Dr. Sarvepalli Radhakrishnan Award, the Best Academician Award for the year 2019 by Andhra University. Awarded Scientist of the Year 2017 by National Environmental Science Academy, NESA, New Delhi. He was in editorial board of Indian Journal of Environment and Eco Planning. He is the member of various professional scientific bodies of national and international repute. He is the NAC assessor and many more. He is a member in various boards of selection committees at national and state level. His earlier selections include UPSC Civil Services Group B Service, UPSC exam in 1985, UPSC Geology Examination All India 11th rank in 1983. Because of his passion for teaching, he is in teaching life. His vision is to see that Adikavi Nannaya University should be the international institute of choice and reputation for education, research, training, and consultancy. With this brief profile, I am privileged to invite Professor Mokka Jagannatha sir to say a few words about this AP and motivate the students and a gathering here. Sir, over to you, sir. Thank you.
Thank you, Dr. Ravi Kumar, for your nice words of introduction. I'm extremely happy to be part of this program today by Central Groundwater Board in association with Adikavi Nannaya University on a public interaction program on aquifer mapping management in Andhra Pradesh state with emphasis on East Godavari district. I could see that there is a tremendous response from a number of students, research scholars, and I came to know that almost 150 plus participants have registered despite a holiday today. That shows the interest of all these participants. I'm very happy to greet Sri G. Krishnamurti Garu and Dr. VSR Krishna, Srimati Caroline Lewis of all the Central Groundwater Board who are here to conduct this program. Along with the convener, Dr. K. Nokaratham, head of the Department of Geology, Adikavi Nannaya University, and other principals. Principal in charge, Professor Y. Srinivas Rao, Executive Council members, Dr. Jagan Mohan Reddy, Professor Ramesh, and other deans, faculty members, and others. Very good morning to all of you. When such public interaction programs are being conducted, we need to congratulate and appreciate the concerned department here, in this case, the Central Groundwater Board. Honorable Prime Minister Sri Narendra Modi ji has often shared his vision of building a new Atmanirbhar Bharat by the year 2022. You may be aware that our great nation is now just completed 75th anniversary of Indian independence. To commemorate the monumental occasion, all departments and ministries have been hosting a number of activities for resurgent Atmanirbhar Bharat on the themes of governance, development, technology, research, and policy, and to know what is happening in different ministries, it is the right decision to conduct public interaction programs and share the knowledge and expertise of these professional organizations like Central Groundwater Board. When you talk about the today's topic of aquifer mapping and management in Andhra Pradesh state, with emphasis on East Godavari district. Hydrogeology, being a geologist, I always fascinated by the subject hydrogeology. Hydrogeology is such a subject, it'll help us in finding the resources of groundwater for the very survival of mankind. When you talk about hydrogeology, the aquifer systems, the groundwater flow, the groundwater quality, the groundwater yield, etc., you need to be a complete geologist. You need to understand the very process, how groundwater gets into the subsurface, how groundwater is allowed to be stored as an aquifer, how the lithology help us to become a good aquifer, what kind of rocks are becoming good aquifers, what is the kind of primary porosity, what is the secondary porosity. So all these things need to be understood to become a good hydrogeologist. So that means you can't say I'm a hydrogeologist without knowing the petrology, without knowing the structural geology, without knowing the geochemistry. So this is all an interdisciplinary subject. Unless you know the lithology, you cannot understand how that particular lithology will become a good or bad aquifer. Unless you know the structure, you cannot understand whether a rock, whether a lithology has a secondary porosity, which can also give a possibility of groundwater occurrence. Unless you know the geochemistry and you don't know how the minerals go into solution and that affect the quality of the groundwater. So in that way, all the students are requested to listen to these experts today. They have been working in the field. They know the different types of aquifers. They know how they take the groundwater into them and become an aquifer, how the aquifers behave with reference to holding the water, giving the quality to the water, and flow of the water. So all these things we need to understand so that the groundwater of a given area can be managed perfectly in an optimal way. The groundwater is not unlimited. How much groundwater is there in a given aquifer? How much we can take out? You should not take excess groundwater from an aquifer and destroy the natural aquifer. We have been looking at in different places, especially in coastal aquifers. There have been indiscriminate use of pumping of these aquifers, especially in the coastal regions, especially in the where the cities are growing, like Vishakhapatnam. So excessive drawing of water using big jet pumps result the destruction of these aquifers and also the impacts like seawater intrusion we could see. So we need to know the groundwater is not unlimited. Groundwater need to be used and conserved. So whatever groundwater is conserved, whatever the water is, rainwater is allowed to go inside as an aquifer, you need to understand how much water you can draw. You need to understand all these management principles should be learned from these experts. It is not only for these public interaction programs should be given to the geology students only. It should be also given to the public because the public are unaware, majority of them, or need to be also given awareness programs. How much water is available? Because the earth and the surface, especially in the urban areas, are concretized. The very little area is left to infiltrate the groundwater. So that is very unfortunate. We have been a number of programs we are proposing, like groundwater harvesting pits and rooftop harvesting pits, etc. I'm extremely happy to say, being a geologist, I have taken a proposal, a project within our campus. We have made a number of rainwater harvesting pits so that all the rooftop water collected from these buildings are allowed to infiltrate into our aquifers. So we have done it last season, and this season also we are doing it, and we have increased the groundwater levels of our campus. And I'm very happy. Again, I have gone back to geology, and I always feel I miss my classrooms. I miss my students because I feel, first of all, I'm a teacher and I'm a professor, and I enjoy that profession more than anything else. So I give my all the best wishes and congratulations. And there are good experts today who will be talking to us, Dr. V.S.R. Krishna and Srimati Caroline Lewis. I suggest all the students to take the advantage of these experts who have been working in the field on this groundwater, aquifer systems, aquifer mapping, quality management, etc. Take and this good information, interact with them, and get the knowledge. Thank you very much, and I wish all big success of this program, of this public interaction program of CGWB. Thank you very much. Thank you.
Thank you, sir. Thank you for the encouraging words to the in this occasion. Now we'd like to start the technical session. I would like to introduce. We'll have a technical session of having two lectures. One is by Srimati Caroline Lewis, Scientist B, Central Groundwater Board, Southern Region, Hyderabad, Hydrogeological aspects and concepts of aquifer mapping and management. Another is Aquifer Mapping and Management in East Godavari District, Andhra Pradesh by Dr. V.S.R. Krishna, Scientist D and Officer in Charge, AP SUO, Visakhapatnam. So the first aspects and the concepts have been devised in such a way that the basic hydrogeological aspects has been covered with what actually we are doing in terms of aquifer mapping and groundwater mounting and resource assessment. Later, Dr. V.S.R. Krishna sir will explain about the aquifer mapping that has been done in sandstone area of East Godavari District, at the same time deltaic area of East Godavari District. Now I would like to invite Srimati Caroline Lewis, Scientist B, Central Groundwater Board, Southern Region, to present the first part of this program, that is on PPT on hydrogeological aspects and concepts. Thank you.
A very good morning to everyone. I'm glad to be the part of this public interaction program on aquifer mapping and management plan with special emphasis on East Godavari district. So today I'll be dealing with the geological aspects and concepts of aquifer mapping and management. So let's get started. So in this topic, I will be covering what is hydrogeology, groundwater occurrence and movement, what is an aquifer, type of aquifer, its properties, state profile of Andhra Pradesh, major activities of CGWB, concept of aquifer mapping and management plan. Let's get started. So we know that water is a prime natural resource, and most of the sectors like agriculture, irrigation, domestic, industrial sectors are dependent on water. So if you see the distribution of water on the Earth's surface, you can see that 97% of the water is present in the oceanic area, and 3% of water is available as fresh water, which is captured in ice caps and glaciers, and groundwater and surface water. So in that 3%, the 30% is groundwater and 68.7% is in ice caps and glaciers, and 0.3% is in surface water. So in today's section, we will be looking after this 30% of groundwater. So what is hydrogeology first? Hydrogeology is a branch of geology which deals with the study of groundwater, its occurrence, its movement, and its distribution. So we will see more about this groundwater today. First, what is groundwater? Groundwater is the water that is present in the pores, fractures of the rock strata in the saturated zone of geological formation. So let's see the vertical distribution of water below the subsurface. You can see there are mainly two zones after the soil zone. So below the soil zone, you can see one zone of aeration and then zone of saturation. So what is zone of aeration? Zone of aeration is nothing. It's a zone where all the pore spaces are not fully filled with water. So maybe that it is partially filled, or it may be filled with some gases or etc. So this is the zone of aeration, and then the bottom zone is zone of saturation. The peculiarity of zone of saturation is it's all the pore spaces are fully filled with water. So the water that present in the zone of saturation is known as groundwater, and the topmost part of the zone of saturation is known as water table, water level, etc. Now we will see. Have you seen a duck well? I think you might have seen a duck well, right? So in the duck well, you can see water level. So what is it indicating actually? It is indicating the top of zone of saturation. So you can assume that the zone of saturation is at a depth of suppose 2 meters, like that. You can by seeing the water level, you can predict. Now there are duck wells, there are bore wells, etc. Duck wells are large and shallow depth wells, whereas bore wells are generally narrow and deep wells. So we will see it in greater depth. And if you see there are two terms generally we use, water level and water table. So water level is when we are measuring from the surface. If you are measuring, we will tell it as water level. Suppose with respect to mean sea level, if we are telling, suppose we will be telling the water table is at an elevation of 22 meter, 222 meter above mean sea level. In the case of water level, we will be saying 2 meter below ground level. So that is a difference between a water level and water table. And the piezometric surface, we will come to this piezometric surface in the upcoming slides. Now, there are two scenarios. So you might have observed the water level. Sometimes, especially in the rainy season, the water level is very shallow. Like you can see a ground level also. You can see water level of within 1 meter, 2 meter, like that. The water level is shallow. But if you observe, you can see a deeper water level in summer season, right? So this difference is known as water level fluctuation. And also one more thing, you can tell that there is a change in the zone of saturation as well. So in the rainy season, zone of saturation will be very close to the ground in comparison with that of summer season. So what may be the reason behind it? Because in rainy season, we used to get a lot of precipitation. It got infiltrated and recharged the groundwater aquifers, and as a result, the water level rises. But in the case of pre-monsoon or the summer season, what will happen? The recharge component will not be there because there won't be any rain or anything. So, but a lot of draft will be there, discharge, like evaporation, evapotranspiration, and apart from that, groundwater will contribute to the river as well. So, due to this, the water level decline during summer season. Now, we will see some of the properties of some of the water-bearing properties of rock. The first one is porosity. Porosity is the water holding capacity of a rock. You might have studied this in sedimentology as well. It's a volume of void space available in a rock material, that is porosity, and it is expressed as the ratio of volume of voids to total volume. There are different type of porosities actually. The two type of porosity. One is primary porosity, and another one is secondary porosity. Primary porosity is the porosity that developed during the formation of rock. So like in a sandstone aquifer, the porosity is like primary porosity. But the secondary porosity is the porosity that developed after the formation of the rock. So suppose you are having a massive igneous rock, but due to the pressure, deformation and all, they're developed enough fractures So in that case, there is a secondary porosity, and this secondary porosity can act as a very good aquifers, which that we will discuss later. And another important term is effective porosity. Effective porosity means even though if you have enough pores, but that may not be connected. If it is connected, that aquifer can act as a very good aquifer. That is known as effective porosity. So in that case, the permeability will be high and the fluid can pass through the medium very easily. So another water bearing property of an aquifer is the permeability, which is the ease with which a fluid can flow through a medium. So the two water bearing property is, one is porosity, another one is permeability. Now, based on these water bearing properties, rock formations are classified into 4 types. First one is our aquifer. So first we'll see what is an aquifer. Aquifer is the peculiarity of aquifer is it's porous, it's highly permeable, and it is capable enough to produce economic quantity of water. So that is a peculiarity of an aquifer. So if you see an aquitard is also porous and permeable, but the permeability is less in comparison to an aquifer. So that's why aquifer, that's a difference between an aquitard and an aquifer. Then aquiclude is porous, but it is not permeable. So it is like a clay and shale, etc. Then another one is aquifuge. Aquifuge is not at all porous, not at all permeable. It's a massive igneous rock. But a massive igneous rock, when got fractured and when it develops secondary porosity, it can be highly, and the fractures are connected, then it can become a very good aquifer as well. So this is all about the classification of geological formation based on water bearing property. It's also known as based on hydraulic properties. Now we will see more about these aquifers. So there are mainly three type of aquifer. One is unconfined, another one is confined, and leaky. So generally, if you are drilling, you have seen a dug well. You know that if you observe the depth, might be shallow. So that is in an unconfined aquifer. Here you can see, here it is a well. So this is your top of saturation zone, and the overlying there is no confining layer. Confining layer means it should be an aquiclude or an aquifuge. So in the case of an unconfined aquifer, there is no confining layer above the aquifer. So these type of aquifers are known as unconfined aquifer, and we used to the top of saturation zone we used to call it as water level. We used to call it as water table, etc. And another one is confined aquifer. In confined aquifer, see, this is a confined aquifer because this is an aquiclude or aquifuge, and this is also an aquiclude and aquifuge or an aquifuge. So in this case, it is sandwiched between two confined layers. So this is an example of confined aquifer. So what is the one difference is that in confined aquifer, the water is under pressure. But in an unconfined aquifer, the pressure is almost equal to atmospheric pressure. So there is no difference in the water level if you see. But in the case of an confined aquifer, the water level may not be the same as the height of top of the confined aquifer because it is under pressure. So that's why the water level rises, may rises. If it is water level is above the aquifer, then we call it as artesian condition. And if it is some cases, you can observe this free flowing. You can see some free flowing wells as well. If you construct a borewell, the water will flow freely. Also, one more thing, and a confined aquifer can act as an unconfined aquifer also. See, if you observe this confined aquifer here, if you see this part, you cannot find a confining layer at the top. So if you drill a well over here, that well will be a unconfined well. That well is tapping an unconfined aquifer in this part if you drill a well. So this the third type is leaky aquifer. Leaky aquifer is like if the confining layer is made up of aquitard. So that case we will be calling it as leaky aquifers. Now we will see some of the important properties of aquifer. One is the transmission property. Another one is the storage property. So what is transmission property? How easily it can transmit, right? So first one is our hydraulic conductivity. So suppose here you can see this is a, imagine this is an aquifer, and this is the thickness of the aquifer. As I have represented it as D, this is the thickness of the aquifer. And this is a hydraulic, imagine the hydraulic gradient is 1 feet by 1 feet. I will discuss what is hydraulic gradient in the upcoming slide. So imagine the hydraulic gradient is 1 feet by 1 feet, and also the surface area, the water that is passed. If you are taking a unit cube, how much in how much speed the water will pass through this unit cube under unit hydraulic gradient. So this is the hydraulic conductivity. It's a in the case of hydraulic conductivity, we are considering a unit cube area, unit cube volume, how much water is passing at a unit time, how much water is passing. That is hydraulic conductivity. Suppose if you are considering the entire saturated thickness, how much water is passing at a unit width, that is known as your transmissivity. So like this is 1 unit. So the transmissivity is the product of hydraulic conductivity and the saturated thickness, because hydraulic conductivity is the unit velocity, but transmissivity is the entire saturated thickness, how much water is flowing through an aquifer. That is known as transmissivity. And transmissivity is dependent on the saturated thickness, because when the saturated thickness reduces, as we have seen, when in the duct wells during summer season, water level is reducing. That means what? Saturated thickness is reducing. So if the saturated thickness reduces, the transmissivity value will reduces. Now we will see some of the subsurface groundwater flow mechanism, how actually the water is flowing. One important thing is hydraulic gradient. So hydraulic gradient means, like suppose you are having a well at a location 1 and this is location 2. You observe the water level, then hydraulic head, that is H1 in well 1 and H2 in well 2. So what is a hydraulic gradient? Hydraulic gradient is also similar to a slope. So it is a slope of water table. In this case, we are telling about the slope of water table. So that is the slope of water table is hydraulic gradient. And we know that in osmosis, water will flow from higher concentration to low concentration, right? So similar way here also the water will be flowing from higher hydraulic head to lower hydraulic head. So this is one principle in which the water flows. And another thing is important factor is permeability, how easily the water can flow through the medium. Now we will see the Darcy's law. What was Darcy's law? The flow through an aquifer medium is proportional to hydraulic gradient and the area through which it passes. That is, it's proportional. That is Q is equal to KIA. Now, Q is your discharge, like volume of water that is passing through this area per day, any in unit time. That is your discharge. And this is K is your hydraulic conductivity. That is the coefficient of permeability, like how easily the water can flow. That is the hydraulic conductivity. I is your hydraulic gradient and A is your area. Because suppose in the Darcy's experiment, I'm not going into depth to Darcy's law, that I think all of them might be doing. So here the area is pi r square, it's cross-sectional area, because this is a cylinder. But if you consider it as a prism, the area will be different, right? So that is how this Darcy's law is derived. Now we will see. We discussed the transmission properties, right? Now we will come to the storage property of an aquifer. So, like first imagine this is Bob. Bob drilled a well over here, and he decided to drill a duct well. So the water table was he drilled the well, and the water table was here. And you can see this is an unconfined aquifer. From this, you can understand that his well is an unconfined aquifer. Now, imagine, now we are taking that. Any problem? Hello? Okay.
Some crosstalk.
Okay. I'm continuing. Okay. Now, Bob drilled a well over here. Then this he drilled in an unconfined aquifer. So because he drilled up to this depth only. Suppose imagine he drilled up to 20 meters. So this is a unconfined aquifer. Then what? Now we can observe what is happening if you are drawing water from this well. What will happen? Suppose this is the surface area image of that well. Assume that, so this is your unsaturated zone, this is your saturated zone, this is your bottom aquiclude, right? Now, you started pumping water, you started pumping water from the well. So, what will happen? The water level reduces and you will get water, right? So, actually, now you can see that there is a now observe this. You can see in comparison to the first picture, you can see there is a reduction in saturated thickness as well. In the case of an unconfined aquifer, and this water is drained actually by gravitational force and actually by the dewatering of the aquifer. So in the case of an unconfined aquifer, the storativity is not a specific yield. What is storativity? The volume of water that is drained from an aquifer, that is drained from the unit surface area of an aquifer under a unit decline in water level. So that is known as storativity of an unconfined aquifer. So here you can find out that the storativity, saturated thickness reduced in the case of an unconfined aquifer when you are pumping, and the water released from an unconfined aquifer is due to the dewatering of the aquifer. So now we will also, some water is retained in the aquifer, and that water is known as that process by which the ratio volume of water that is retained in the aquifer is known as specific retention. So the porosity, this equation you might be doing, porosity is the combination of sum of specific yield and specific retention. Now we will see the storativity of the confined aquifer. Tina drilled a bore well at this location. What she did, she drilled up to here, and there are two because this is a confined unit, because this is an aquiclude, and she drilled up to 150 meter, and then she observed that the water level she got up to here. So the water level in this well is not a water table, it is a piezometric surface. It is not a piezometric surface. Now we will see what will happen to the well if we are pumping the water. Suppose this is the section of that well, and here you can see the aquiclude, and the piezometric surface is here. So what will happen when you are pumping water? Started collecting water. Still you can see this. There is no change in the saturated thickness. The saturated thickness remains constant. Now, how in the case of a confined aquifer, the water is released from the storage by the depressurization of the aquifer. So here it is a unit decline in the head. How much volume of water released from the unit decline of head is known as your storativity in the case of an unconfined aquifer, but the water is released by the depressurization of the aquifer. Now we will compare. You can see, you can just check the volume of water that has collected by a unit reduction in the hydraulic head. In that, you can see this is a case of an unconfined aquifer. This is a case of a confined aquifer. So in the case of unconfined aquifer, what happened? The saturated thickness also reduces. But in the case of confined aquifer, there is no change in the saturated thickness. But if you see the yield, how much volume of water that has collected, in the case of confined aquifer, you got very less volume of water. So the storage, we can say that the storativity of a confined aquifer is less than that of unconfined aquifer. Now we will see, this is the storativity. This is all about the storativity of an confined aquifer. But if you take the specific unit volume of the aquifer, how much water is drained, That is known as specific storage. This is also one more terminology which we use in hydrogeology. That is a specific storage, similar to hydraulic conductivity. Here it is like unit volume, how much water we can extract by a change in unit head. That is known as specific storage. So the storageivity is a product of specific storage and the saturated thickness. And now almost all the parameters we have learned, that transmission properties, storage properties, etc. Now we'll discuss how in CGWB we used to estimate, generally how we used to estimate these aquifer parameters. One is by the preliminary yield test, another one is slug test, and then by the pumping test. So we used to get that transmissivity, storageivity value from the these tests. In a pumping test, actually, what is happening? We used to pump water from a well, and the fall in water level is measured in the pumping well and the nearby wells. So what you can see here. So this is an extra. You are from this well, we are pumping. Actually, what is happening? You can just see. So what is happening? The water level goes down. At time T1, you are continuing your pumping. So at T2, the water level goes again down, then down, then down. So this the change in water level. See, this blue line is indicating the static water level. From the static water level, the how much your water level is going down, that is your drawdown. So, we used to measure this drawdown regularly during a pumping test. And one more important thing is that you can see during pumping, actually what happened, there create a cone of depression. So actually this is a vertical section, but you need to imagine it 3D. So in a 3D way, there is a cone is created near to this ground near to this well when you are doing pumping. So I hope we have covered almost all the basics of hydrogeology up to this. So we have seen what is groundwater, what is a vertical distribution of ground means water in the earth, and the water bearing properties of the aquifers, that is porosity and permeability. Then based on this porosity and permeability, aquifers are based on the porosity and permeability, rock formations are classified into aquifer, aquiclude, aquifuse, and aquitard. And then we discussed about the aquifer. Aquifer is the porous and permeable unit which is capable enough to yield water economically. And then we have discussed type of aquifers, that is confined, unconfined, and leaky. The major difference between confined and unconfined aquifer is, in unconfined aquifer there is no confining layer, but in a confined aquifer there is a confining layer. And the water level of a confining aquifer is the top of saturation zone. And in the case of unconfined aquifer, it is known as piezometric surface. And then we have discussed about the transmission properties of these aquifers and the storage properties of these aquifers. Now we will see is the state profile of Andhra Pradesh. So Andhra Pradesh is having an area of 1,62,000, nearly 1,63,000 kilometers square, with a with coastal plains. Then you have your Eastern Ghats Formation, and then Western Peneplain, and you have Godavari, River Penna, and River Krishna. And most, if you use the if you see the utilization of groundwater, around 38% of the water is used for the irrigation purpose. Surface water contributes 62%. If you see the rainfall distribution, the rainfall varies from 561 mm to 1130 mm. And Andhra Pradesh consists of 30 districts with 664 mandals. And if you see the geological setup, you can see here, you can see most of the areas are around 84% of the area is hard rock metasedimentary areas, and the remaining by semi-consolidated formation and post-alluvial formation. And the thickness of weathering varies from 5 to 20 meters. Now we will see what are the activities of CGWB. We are mainly responsible for the groundwater monitoring, groundwater assessment, groundwater management and regulation of Telangana and Andhra Pradesh state. We are monitoring groundwater 4 times in a year, and we are carrying out exploratory drilling. We are preparing micro and micro level groundwater management studies, and we are assessing groundwater resources, and we are doing capacity building and mass awareness campaigns, and advising state and other agencies. We are generating a lot of publication. We are part of Groundwater Authority, and we are now the one of the most prestigious project we are doing, Aquifer Mapping and Management. Now, this is a groundwater monitoring wells which is available in the Andhra Pradesh state. You can see that around we have a network of 864 groundwater monitoring wells with 699 dug wells and 165 piezometers. So you can see the water level. So we have learned about water level, right? So here you can see in the Anandapur, Chittoor, Kadapa area, this is a summer season, that is pre-monsoon season water level. In the Anandapur, Chittoor and Kadapa area, you can see the water level is deeper than 10 to 40 meters. So this is the summer season scenario in comparison to coastal area. We have deeper water levels in this part of the area. Now, groundwater resource estimation is one of the major activities because we are working together with other stakeholder departments like state groundwater, agriculture, irrigation, economic, statistics, NABARD. To get a whole picture of the groundwater resource availability and extraction and future allocation. And this is the total available groundwater availability is 20,000, nearly 20,000 MCM. And this groundwater resources estimation, this acts as a base for planning and implementation of any development project in terms of agriculture irrigation under Pradhan Mantri Krishi Shishya Yojana and Adal Bhujal Yojana. Now we comes to our national Aquifer mapping program. So actually what was happened, the number of borewell was increasing, like there was a sudden increase in the number of borewells in the country. So what CGWB with other government decided to move from groundwater development to groundwater management, because there was a crucial requirement, because the groundwater was not properly managed. So there comes the idea of national Aquifer mapping. So in this, what we are actually doing is this national Aquifer mapping is also known as NACU. This is a scientific study in which we integrate geology, geophysics, hydrology, then chemistry, everything. We integrate together and we are bringing it into a GIS platform, and we are making maps, and we are preparing the aquifer management plan. And actually, we are delineating aquifers in terms of quality and potential for the suitability for drinking and irrigational and industrial use. So, we are preparing a sustainable management plan considering proper demand and supply side measures with the community participation. So, Krishna sir will be explaining about the how about the East Godavari district, so you will be understanding how actually we are doing aquifer mapping. Now this is a 3D. This is the 2D and 3D aquifer disposition models we are preparing. Here you can see. You can see aquifer. Then you can see aquifer 1. You can see here. Then you can see an aquiclude. Then you can see an aquifer again. Here you can see another aquiclude. Then you can see an aquifer. Sorry, and this thing is actually an aquiclude. This is a massive granite. So this is an aquifer. Likewise, we are delineating the aquifers in terms of potential and quality. And these management studies will contribute significantly to resource management tools for long-term aquifer network monitoring network and conceptualization of and quantitative regional groundwater flow models used by planners, policymakers, and other stakeholders. Now, these are some of the images which as the part of aquifer mapping we did. So this is study the area, then weather thickness. Here you can see some fractures. Then part of aquifer mapping we are doing. We have a lot of data gaps. We were having a lot of data gaps. So to overcome that, we were doing a vast exploratory drilling and vertical electrical sounding to generate additional data to for the best models. Now you can see the management part. We are doing artificial recharge structures. We are proposing that water conservation in all sectors. Then exploring advanced desalination technologies, conjunctive use of surface and groundwater. Then we are we are doing awareness program, virtual water trade, groundwater monitoring through participatory approach, etc. Now, these are some of the recharge structures. It includes CDs, PGs, etc., which we are constructed a part of NACU. And this is in urban areas. We are doing rainwater rooftop rainwater harvesting, recharge peak trenches, storage tanks, etc. Now, this is a part of NACU. We are doing capacity building as well. Thank you.
Thank you, Carolyn. If students and the participants have any clarifications or any want to clear their doubts, they can. We have another 5 minutes time for interaction. You can put whatever your questions with Carolyn, and she can try to explain. So, if there are no doubts, we can go to the next part of this program. Okay. Now, I would like to invite Dr. VSR Krishna Garu to say about Aquifer Mapping and Management in East Godavari District, Andhra Pradesh.
Thank you, Mr. Ravi. Am I audible?
Yeah, go ahead.
Yes, yes.
Your voice is.
Am I audible?
Yes, yes.
Yes.
Go ahead.
Thank you. Professor Jagannath Rao Garki, Professor Ashok Registrar Garu, Professor Venkatesh Rao Garu, and Professor Srinivas Rao Garu, Geology Department, and Professor Nukratnam Garu, and our Regional Director Krishnamurthy Garu, and our surprise participant, Dr. Anand from RGI, and other participants and students and friends. Sir, is there any language problem? Can we go ahead in the local language to some extent? Say yes or no.
Okay, you can go ahead.
Yes.
Thank you. సార్ అందరికీ నమస్కారం సార్. మా గురువు గారులు అందరూ చాలా మంది ఇక్కడ ఉన్నారు. సో వాళ్ళ ముందు నేను చెప్పడం అనేది కొంచెం నాకు ఇప్పుడే వాళ్ళందరూ వచ్చిన కొంచెం నాకు ఇంత ఎక్స్పీరియన్స్ ఉన్నా కానీ కొంచెం డౌట్ వస్తా ఉంది నా ప్రెజెంటేషన్ మీద. ఎనీవే లెట్ మీ ట్రై. ఐ థింక్ యాక్చువల్లీ ఐఎమ్ సో యాక్చువల్లీ మిస్ కరోల్నా she has cleared everything, so she made me నాకు చాలా పని తగ్గించింది. I did not explain all the parameters. అసలు ఏం జరుగుతుంది ఇక్కడ అనేది మనం చూద్దాం. ఆంధ్రప్రదేశ్ యాక్చువల్లీ నాక్యూమ్ అంటే ఏంటి అనేది అన్ని ఎక్స్ప్లెయిన్ చేశారు ఆవిడ. మనకి ఆంధ్రప్రదేశ్ లో మొత్తం 14 రకాలైనటువంటి రాళ్ళు ఉన్నాయి. దాంట్లో డిఫరెంట్ ప్రాపర్టీస్ ఉంటాయి. వాటికి ఒక్కొక్క ఫార్మేషన్ ఒక్కొక్క రకంగా దాని వాటర్ స్టోర్ ఉంటుంది. మనకి కావాల్సినప్పుడు తీసుకోవచ్చు. ఆ ఉన్న వాటర్ కూడా క్వాలిటీ కూడా వేరీ అవుతా ఉంటది. సో లైక్ దట్ 14 డిఫరెంట్ రాక్ టైప్స్ ఆర్ దేర్. సో ఈచ్ రాక్ టైప్ ని మనం అర్థం చేసుకొని మనకి కావాల్సినప్పుడు అది వాటర్ ఇవ్వగలుగుతా లేదా, మనకి కావాలంటే దాన్ని ఏం చేయాలి, క్వాలిటీని ఇంప్రూవ్ డిటరేట్ కాకుండా ఉండాలంటే ఏం చేయాలి, అవన్నీ కావాలంటే మనకి అన్నిటి యొక్క యాక్యువర్ ప్రాపర్టీస్ అనేది కావాలి. ఇందాక కేరళ మేడం చెప్పినట్టుగా. సో ఒకసారి మనం రాక్ ప్రాపర్టీని అర్థం చేసుకున్నప్పుడు దాన్ని మేనేజ్ చేయడం అనేది, ఎప్పుడైనా సరే డాక్టర్ దగ్గరికి వెళ్ళినప్పుడు యూ విల్ స్టడీ ఆల్ ద థింగ్స్, దెన్ యూ విల్ గివ్ డయాగ్నోస్ and you will give the medication to come to the normalcy, to become the patient is active. So similarly, that is only the maximum outcome we have to. So let us go to the straight away into the topic. I think time koncham constraint anukuntunnanu nenu. Ravi garu chinna request oka 5 minutes mundu nannu caution cheyandi sir. Time. Okay.
Sure sir. Carry on sir.
Now this is East Godavari district. ఈస్ట్ గోదావరి డిస్ట్రిక్ట్ ఆదికవి నన్నయ్య గారు, ఆ నన్నయ్య గారి పేరుతోటి యూనివర్సిటీ పెట్టిందంటే, యాక్చువల్లీ ఐ హ్యావ్ సమ్ రిలేషన్షిప్ విత్ దిస్ యూనివర్సిటీ. సమ్ 4 years back I visited this university. At the time, university authorities, I think Professor Ashok was at the time registrar. I think it was in 2017 or 16 must be. He has helped a lot, and at the same time Professor Srinivasarao garu kuda చాలా కోఆర్డినేట్ చేసి, ఎందుకంటే నాకు కొన్ని యాక్విఫర్ ఎక్స్టెన్షన్స్ లో వెల్స్ కన్స్ట్రక్ట్ చేయడానికి నాకు కొన్ని పర్మిషన్స్ కావాల్సింది. పర్టికులర్లీ కాకినాడలో యూనివర్సిటీ సెంటర్ ఉంది, పీ సెంటర్ లో, దాంట్లో పర్మిషన్ కోసం అప్పుడు నేను యూనివర్సిటీని కాంటాక్ట్ చేసినప్పుడు దేవర్ సో చాలా హెల్ప్ చేశారు. ప్రొఫెసర్ శ్రీనివాసరావు గారు కానీ, ప్రొఫెసర్ అశోక్, అట్ ద టైమ్ రిజిస్ట్రార్ వైస్ ఛాన్సలర్ గారు, వీళ్ళందరూ విత్ దయర్ హెల్ప్ వీ కుడ్ డ్రిల్ 3 wells ఇన్ కాకినాడ పీజీ సెంటర్. నౌ let us go to the East Godavari. Actually, East Godavari, it is almost linear from. Hello. Okay, I am proceeding. If any I am not audible, just caution me. Okay. So East Godavari district, ఎన్ని చాలా మండలాలు ఉన్నాయి. It's almost top to bottom linear, and it is further divided into so many. And the south, it is Bay of Bengal, and rainfall is very good rainfall. 1300 నుంచి minimum అయితే 1000 mm పడుద్ది, and like that it's good rainfall. Rainfall wise season rainfall ఎప్పుడు మనల్ని తక్కువ చేయలేదు ఈస్ట్ గోదావరి డిస్ట్రిక్ట్ ని. అండ్ స్లోప్ తీసుకుంటే నార్త్ ఈస్ట్ సౌత్ కి ఆర్ నార్త్ వెస్ట్ సౌత్ వెస్ట్ ఫైన్ రైన్ఫాల్ పడదంతా కిందకి.
ఎస్టేట్ ఆఫీసర్స్ లేనప్పుడు కదా.
Pardon sir?
Sir,
some crosstalk.
No, if any problem comes, just caution me. Otherwise, I'll go ahead. I will not stop in between. Okay. So because of that rainfall and great slope, the drainage pattern is clearly showing north to south almost. And you see, observe up to north middle of the district, the drainage is good. Whereas from there, drainage is almost nil. So what are the reasons? Let us study later. Now, if you see the geology, earlier ఇంత ముందు మనం ఆంధ్రప్రదేశ్ మ్యాప్ చూసినప్పుడు మొత్తం 14 రాక్ టైప్స్ ఉన్నాయి అనుకున్నాం. దాంట్లో 6 ఇక్కడే ఉన్నాయి. 6 నార్త్ లో 3 ఉన్నాయి, సెంటర్ లో 1, అండ్ సెంటర్ లో 1లో మళ్ళీ మధ్యలో ఇంకొకటి ఉన్నది, దాని కింద ఇంకోటి. దిస్ ఇస్ అలూవియం, శాండ్ స్టోన్స్, విత్ ఇన్ ది శాండ్ స్టోన్ మధ్యలో basalt, this is the third one, and chornacites, condolites, and gneisses. Totally 6 rock types out of 14 of Andhra Pradesh in East Godavari we are having. So if you see the rod from top to bottom, so ఇందాక వర్షపాతం బాగుంది, రాక్ టైప్స్ కూడా అన్ని సహకరిస్తున్నాయి నీళ్లు వెళ్ళడానికి. సో వాటర్ లెవెల్ కనుక చూస్తే గ్రౌండ్ లో ఉన్నట్టు వాటర్ లెవెల్ ఎట్లా వెళ్ళొద్ది, ఏంటి పారామీటర్స్ అన్ని ఇందాక కేరళ మేడం ఎక్స్ప్లెయిన్ చేశారు. లెట్ us not go into the deep into those parameters. So if you see the overall the pre-monsoon, వర్షాకాలానికి ముందు వాటర్ లెవెల్, గ్రౌండ్ లో వాటర్ లెవెల్ ఎట్లా ఉంది, మిడ్ వరకు ఇట్ ఈస్ లిటిల్ బిట్ డీప్, ఇట్స్ 5 to 10 meters, అండ్ ఫ్రమ్ సెంటర్ నుంచి కిందకి అంతా less than 5 meters ఉంది. సో rainfall తోటి వాటర్ లెవెల్ కూడా బాగుంది. సో there is no issue. Once after rainfall, you see the water levels it's become shallow, but whereas this part, it is in deeper levels. Let us see what is the reason for it. So if you read overall the groundwater potential, అంటే మనకి వాటర్ ఎక్కడెక్కడ అక్కర్ అవుద్ది, ఎంత అక్కర్ అవుద్ది అని అనుకుంటే ఈ క్రిస్టలైన్స్ అంటే ఈ గ్రీన్ కలర్ లో ఉన్నటువంటి వాటిలో అప్ టు 1 to 2 LPS ఉంటుంది. వేరే శాండ్ స్టోన్ ఇట్ ఇస్ 3 to 5 LPS ఉంటుంది. అలూవియంలో ఎక్కువే ఉంటుంది, మోర్ దాన్ 5 LP అంటే 5 liters per second దాకా ఉంటుంది. అంటే ఓవరాల్ గా లెస్ దాన్ 1 నుంచి మోర్ దాన్ 5 liters per second వరకు మనకి ఇది ఉన్నది. ఇది ఓవరాల్ గా చూసుకుంటే మనకి క్వాలిటీ పాయింట్ ఆఫ్ వ్యూలో కూడా 750, 1500 మిడిల్ వరకు ఉంది. అలూవియం వచ్చేసరికి అక్కడక్కడ కోస్టల్ ప్యాచెస్ లో 3000 వరకు ఈసీ ఉంది. అంటే కొంచెం బ్రాకిష్ నేచర్ అనేది సౌత్ లో కనపడుతుంది. బట్ ఓవరాల్ రెస్ట్ ఆఫ్ ఇఫ్ ఎవ్రీథింగ్ ఇస్ ఫైన్, రెయిన్ఫాల్ బాగుంది, రాక్ టైప్స్ ఎంకరేజ్ చేస్తున్నాయి, వాటర్ని అలౌ చేసుకుంటున్నాయి, అండ్ దానికి అనుగుణంగా రెయిన్ఫాల్ పడ్డప్పుడు వాటర్ షాలో అవుతుంది, క్వాలిటీ బాగుంది. సో నాట్ మచ్ ప్రాబ్లమ్స్ ఇన్ ఈస్ట్ గోదావరి డిస్ట్రిక్ట్. Am I right? Now, before going studying anything, we have to understand the area lo what is the geological evolution in that area. So let us see the outer line. This is the outer line of the East Godavari administrative boundary. It is not the geological boundary, it is only administrative boundary. And sometimes we have to study the adjacent part of the formations also when we plan anything scientifically. Of course, we have to consider it restrict our studies, administrative implications to administrative boundary only. Then it's the geological evolution. Let us see. These are the crystallines earlier, initially. So for students, I did not explain what is the age of the crystallines. That is Precambrian or Archeans, whatever you call. Then this is the Gondwana land. At the time of Gondwana, sandstone, entire up almost mid of the district further till Bay of Bengal, it is a sandstone only. And within this sandstone also there are two types, particularly East Godavari concerned, and in between basalt also, basalt flow also there over the bottommost sandstone. Then alluvium, because of the Godavari load, river Godavari carries a heavy load of the sediments. It is to bring the load, carry the load and dump whenever the velocity reduces. That's why this alluvium has formed. That's called delta. That is called Godavari Delta, eastern part of the Godavari Delta. Now let us see what are the formations within the crystallines. There are three types. One is, you see, very easy to understand the stratigraphy, to remember the stratigraphy of the East Godavari. What is the first part? Here it is only, it is a condylite. Then comes dark green is the charnockite. Then the light green is gneiss. Then the alluvium, sandstone. And let us go to the sandstone part. Within the sandstone only, there are upper Gondwanas of Tirupati sandstone. Then the flow is there over the Tirupati sandstone, basaltic flow. It is almost everywhere it is there, but at some places, continuity is not there. Then younger formation is sandstone. There is a Rajahmundry sandstone. There is a tertiary sandstone. Then this is the deltaic alluvium. Because of the Godavari, it has carried, and by losing the velocity, it is deposited the alluvium. Now let us, because it is having the properties, different properties up to crystallines. From north to mid, it is a crystalline. In the mid, there are the sandstone within that trap. Then alluvium, covering alluvium entire southern portion. Because this is the, as Ms. Carolina mentioned about the primary porosity, second porosity, and no porosity, like that. Let us talk. If you see the northern portion, there is a crystallines which are having the three different class types. It is a lack of the primary porosity. Am I right? It's the lack of primary porosity. Only secondary porosity is there. Because of the lack of the primary porosity, the water, yield of this formation is very less. And whereas here sandstones, it is having the primary porosity at to some extent sometimes, and secondary porosity also very rarely. And whereas the traps, it's a little bit, it's not much studied because of the very thin layer is occurring. Then it is having the good potential and quality also good, not much sediments. Whereas alluvium, it's a good example for any aquifer, primary porosity only. When compared to sandstone, it is having the high porosity, and whereas here it is since it is deposited in the marine environment, the quality problem is there. If you see the quality wise, quantity wise, less yield up to middle, and middle is very good yield, and alluvium is very high yield. High yield means minimum of 5 LPS to you can expect up to 20, 30 LPS also there. And quality wise, if you see from up to middle, it is quality is good because there is not much interaction of the groundwater with the rock formation. That's why it's not, and also it is very hard formation. That's why it is not diluting into the any water, and it's giving the good quality. It's expected is around 70 to 1000, and sandstone also good quality, whereas alluvium, it's a vertically there is a lot of variation. Let us study in the detail. So for the easy sake, let us divide the district into 3 parts: northern part, central part, and southern part. If you see the overall, understand the geological evolution. If you see this is the condylite, gneiss, and charnockite, and that is sandstone is resting over the condylites or gneisses, and in between basalt flows are there. Then the tertiary sandstone, that is nothing but Rajahmundry, and this is the top youngest is alluvium. This is the sea, and the Nannaya University is almost it is sitting somewhere here, because there are if you entrance of the gate, main gate, that is the Rajahmundry sandstone. If you come to the registrar office or VC building, from there it is the trap starts. If they cross their campus backward, that is towards north, they are going to enter into the Tirupati sandstone. You are lucky enough to study all 3 formations daily, watching 3 formations daily, right from Rajahmundry, trap, and sandstones. And if you are having any time or weekend, next weekend, you can make a one traverse from. It is not much for it's for students. It's very easy because you are youngsters. You cross. You have a one traverse from Dosakayalpadu, that is Rajanagaram. From Rajanagaram, one road goes to the airport. So if you cross over that road from Dosakayalpalli to the Rajanagaram, or little bit further Rangampeta and Peddapuram, you can study all these formations of the crystallines, Tirupati sandstones, basalt, and one very beautiful section is there near Rajanagaram on that airport road, basalt cross section you can observe in Edagwell. So all these formations you can observe very easily. You try to explore yourself. So if you make it to understand this, it is very easy. The same thing we are observing horizontally here we are saying now vertical. If you see, this is the crystallines, then the Gondwana sandstone, this is the trap, and the Rajahmundrys, and this is the recent alluvium. It's very thin sheet of the alluvium, and at a delta it is very thick, huge up to 2 to 3 kilometers also thickness. And whereas basalt, here basalt is in Rajahmundry. There was a well in Tubaika Research Institute. The well was drilled. They started in the Rajahmundrys and they ended in Gondwanas. The thickness of the basalt is 45 meters. So this basalt thickness is varies from place to place. And this is the same sequence, it is reflecting in a tabular form. Because you have to understand, unless until you understand the geology, as Professor Jagannatha Garu mentioned, nothing you can manage, nothing you can plan. So geology is the base. You have to understand the geology basically. Then only you can plan further for groundwater managing or understanding the aquifer system. Now let us go to the crystallines only. So these are the crystallines of condylites, charnockites, and these are the gneisses. So these are all the 3 major rock types, and structural hills, and then pediment zones. Structural hill followed by pediment, then pediplain. So pediments are the recharge zones where the rainfall infiltrates. Since the primary porosity is less, there is a heavy runoff over this area. The entire water is moving north, south, or so northeast to southwest, a little bit, not west to the southeast. So these are formations are not of good aquifers when we call it as an aquifer point of view. So these are the properties of the crystallines. And actually here in this crystalline area, we are having some gaps. And recently we have undertaken this, again, we have taken up these studies. And recently last month or before last month, my colleagues have covered geophysically, vertical electrical soundings and other geophysical studies they carried out. Still we had to finalize. We are having idea, the management plan, but still we have to refine that management plan. So in this crystalline formations, it is weathered and a little bit semi-weathered to weather massive, and then fracture, semi-weathered and fractures. These fractures are sometimes 15 to 20 meters and around 50 to 60, and very deep fractures are rarely occurs in this area. And overall, the general range of the fracture occurrences in 30 to 60 only. If you go beyond 200 meters, rarely in this area we have not yet studied, but in chornoclates, chances are very meager, whereas gneissic formations, they are good, fractures are occurring, and whereas chondrites, overall, compared to these two, chondrite is good, but because of the colonization, these fractures and falling problems are there. So overall, the crystallines are, because of the lack of primary porosity, and to some extent, secondary porosity like fractures, where there are some problems in this. So secondary porosity occurs in only weathered and fractured. These are the very poor aquifers. Yield is very less. It's rarely occurrences are occasionally it's some 2 to 3 LPS we are getting. Otherwise, it's very less, and the transmissivity also very low. And groundwater quality is very good. It's up to 750 to 1000 is the higher side. So these are the issues. During summer, you find frequent these type of scenarios in that area. By seeing that, just you have roam in an area, that area, to understand that area. Particularly, these are all low yield wells. They're driving. They're bringing the water from the springs. There are some springs which are not being maintained properly, and because of this spring water, they are facing health problems. So these are the issues because of the low capacity. So these are the things. Not much developmental activity in this area. Even then, management strategies we have to follow, like wasteland water development program and irrigation and desilting of the existing tanks and the rejuvenation of spring. This is the prime factor. Particularly, I think Maredmilli and other areas, particularly from the Chodavaram, Rampachodavaram and further north, Sitapalli and other areas, you can observe some of the springs. If you rejuvenate the springs means you have to study the spring and its catchment, and you have to renovate that springs. So this is one of the management aspects. Now we are identifying the recharge zones, like, and identifying the lineaments and fracture pattern based on the geophysical studies as well as the hydrogeological studies. So these are about the crystallines. Now let us come to the sandstones. Sandstones, again, these are the, within the sandstone, this is nothing but it's a middle formation. Exactly center of the East Godavari district is your basaltic formation. And one more thing you observe, northern tip of this basalt, your highway passes. And southern tip of this Rajahmundry sandstone, the contact of in between Rajahmundry sandstone alluvium, your highway passes. So these are the stable, because geology itself is an indicator for the civil engineers to plan for the railway track as well as the highways. Geoengineering professionals like Professor Venkatesh Ragar, I think he will throw light after some time on this thing. So geology also helps a lot. Your university is exactly, I think it is somewhere here. That's why you will get Rajahmundry sandstones and thin patch of the, your buildings or main buildings are within the, sitting on trap, I think so. If you go further north, means downward, you will find Tirupati sandstones. So, And there is a, because of small streamlet, that alluvium covered over the sandstones. So when comes to the sandstone formation itself, this upper Gondwanasar Tirupati, they are little bit compact. The yields are little bit less when compared to other formation, that is Rajahmundry. And trap, in between trap occurs, it is a lying over the Tirupatis and underlined by the Rajahmundry sandstones. Below these traps you can find. So this quality is not much, only quantity is very good. Then what is the problem in this? Quality is good, quantity is good because of the rainfall, because of the lack of the primary porosity, crystalline water, the water is coming to this area, it is being percolated, but quality is good, quantity is good. Then let us think what are the problems in this area. So before study the problems in that area, let us understand the geological scenario of this state by cross sections. As earlier speaker mentioned, we are drawing the cross sections to understand the geological succession of that area and behavior of the things. And actually, this entire formation wise we have studied this entire sandstone area, right from East Godavari, West Godavari, and part of Krishna district. So in East Godavari, only upper Gondwanas and tertiary sandstone, that is Rajahmundry. When it's come to the lower Gondwanas also, the Gollapalli sandstone is the oldest. And in between, you'll find the Raghapuram shale. This is creating a problem. Raghapuram shale for the recharge studies, recharge projects, and in between trap, then Rajahmundry sandstones. So these are the sections based on the our hydrogeological surveys, geophysical, as well as the exploration wells to confirm whether our observation is correct or not, our interpretation is correct or our inference is correct or not. We drill wells. So in Peddapuram area, we have drilled 600 meters depth well. So it has crossed Rajahmundry sandstone, trap, as well as Tirupati, and we have not touched the alluvium at that place. This is this is a block diagram. If you see the sequence, Rajahmundry's trap, and this is nothing but from your university. It's very near this section. And here also it is, you can see the slope from north to south. And you see, this is only sandstone, Rajahmundry sandstone. This is only lithological, not unit. It is only stratigraphic unit, Rajahmundry sandstone. Then within the Rajahmundry sandstone, there is a sandstone layer, and in between that is a pervious and impervious. It is a shale, or you can call it as a clay for easy purpose. And again, sandstone, then clay, like that. There are some 4 to 5 aquifers. This is the top aquifer. You can call in between this a second aquifer, third aquifer, 4, 5, like that. 4 to 5 aquifers were identified within the Rajahmundry itself based on our field activities. So now we have to understand each layer. What is its property? Whether it is, as my earlier speaker mentioned, whether it is unconfined or confined, or is it leaky aquifer or non-leaky aquifer. So see, in this is very clear-cut example. You can observe some, what do you call, some structural features are there. Bedding is there, whether it's a cross bedding or something else bedding. That students can analyze and report me after end of this lecture. And sandstone, and in between it is a shale or clay impervious layers. These like this in sandstone you'll get. How to identify these? Because in drilling you'll let litholog, it's very vaguely prepared, litholog sandstone, and it's very difficult in particularly rotary drilling to observe the sample particular of that depth. So there, this geophysical logging helps a lot to understand the aquifer disposition, particularly within a formation. So this is the geophysical log of the long normal, short restrictive logs of right side is the restrictive log, that is a long normal and short normal, and this is left side is the SP. SP indicates what is the quality and as well as the quantum of the formation, whether formation is having the thing or not, water is having or not. If you observe particularly this portion, you see straight line of the SP. That means this formation is not having the water. It are not yielding any water. It's like a confining layer, or you can call it as a clay or shale. And here also, if you see, if the clay, what is the resistivity of the clay? It will have very less resistivity. That's why it's almost flat. So it is highly resistive, and here also this is potential. And whereas here, if you see low resistivity and no SP, that means this is clay or impervious layer. This is a pervious layer, because resistivity has developed as well as SP also developed. So based on this, we have identified different aquifers. Based on this only, we are saying 4 to 5. It's a multi-aquifer system of Rajahmundry sandstone. It's not a single aquifer, it's a multi-aquifer. So by this, we can conclude it's a very helpful tool, logging. Based on the logging and our field observation and lithological log, we can analyze whether it's a single aquifer system or multi-aquifer system. Overall, if you consider the pumping test, what earlier speaker has explained, T and S and other things. So in Rajahmundry sandstones, in this East Godavari and adjacent areas, the thickness of the Rajahmundry sandstones is 324 meters. That is a maximum thickness. And this our studies reveal, and the discharge is very good. It's 15 to 35, minimum of 15, 35 LPS, liters per second, 35. There's a transmissivity also high, and quality is very good. This quantity is good, quality is good. And when the Tirupati formations, as I mentioned, these are a little bit compact, the yields are comparatively less than Rajahmundry's. The transmissivity value is also less. So when you plan for any need for the artificial recharge, it's better we have to consider this Rajahmundry formation when compared to Tirupati formations. So these aquifer parameters and other studies will help to manage our aquifer. If you see the shallow aquifer as well as the deeper aquifer, let us say shallow means nothing but it is a unconfined. Deeper aquifers means these are the, what I mean to say is, this is the top is shallow aquifers and these are the deeper aquifers. In quality point of view, both are having the good quality. And EC is the maximum of 2,000 to 3,000 is higher side. So both shallow and deeper are both potable for the drinking as well as the things. Now, what are the issues in sandstone area? As we mentioned, quality is good, quantity good, then people will explore that area. पानी आ रहा है तो निकाल दे నీళ్ళు వస్తున్నాయి అంటే అందరూ ఎగబడతారు కదా అట్లాగే నాకేంటి పోతే పోయినాయి అక్విఫర్ పాడైపోతే పాడైపోతే నాకు వస్తున్నాయి గవర్నమెంట్ కూడా లిటిల్ బిట్ పాజిటివ్ సైడ్ ఫ్రీ కరెంట్ that free current, anyway, this is not the forum to discuss about the free current. So that is creating a problem and it is disturbing our aquifers, our natural system. You see the increase in tube well irrigation. The earlier hectares from 220,000 to it has increased to almost 3 lakh hectares per annum. It's almost, I think it's around 60 to 70,000 hectares increased within a span of 6 to 7 years. You see the increase in tube well irrigation area wise. And you see the, in particularly sandstone area, 77% is depend on tube well only, that is groundwater. And surface water is very less, 22%. Because once the Polavaram Canal comes, hope this scenario may change. Let us hope. When it comes, question mark. Let us not discuss. So because of this tube well irrigation, more 77%, it's almost tube well. Groundwater only we are utilizing. So that is creating a problem or depleting groundwater levels. And sustainability. Water level deplete too, as well as the yields also decreasing. Because as earlier speaker mentioned that thickness of the saturated zone is reducing. So, and when the wells are increasing, number of wells are increasing, water levels are declining. Because of the declining in water conditions, the power consumption is increasing. So financial burden is increasing. So these are the reasons. So reasons are groundwater extraction, increase in cropped area. So this is the main issue, particularly in sandstone area. So is it really the decline in water levels? Water levels in phreatic aquifer is mainly, it's almost less than 10 meters only. Majority of the areas 2 to 5 meters. And at some places like Pedapuram area and Gandepalli, Mallepalli, and some of the areas like some part of the, I think it is Kadiam part also, a little patch, they are little bit deeper water because the groundwater is being extracted for irrigation as well as the floriculture. Then when it comes to the piezometric head is nothing but it's only water level. It's also water level, only the deeper wells. It's which are under the confining condition or semi-confined condition. The water levels are, you see, in between Pedapuram to Rajahmundry north, that is Gandepalli and Mallepalli and Rangampeta, to some extent Dosakailpadu and other areas, it's up to 70 meters is the water level. You see, top aquifer is up to 5 to 10 meters, whereas the 60 to 70 meters is the deeper water level. Is it one place or different places? At one, let us check it. This is the place called Gandepalli, where the shallow aquifer, the first aquifer, whatever the first visible aquifer or inferred aquifer, water levels are within the 0 to up to maximum 10 meters only. You see the long period stretch. It's almost flat, not much variation, no decline. By seeing this graph, one can say it's a good groundwater point of view. Is it so? Let us check it. When it comes to the same area, Gandepalli only, the piezometer, that's a deep water level, deeper bore well, that's up to 120 to 140 meters well. The water level is, present water level is around 70 meters. And if you observe the trend earlier during the early 2000, it is about 45 meters. Now it is up to 70. Present scenario, yesterday I inquired, it is around 73 meters during the last summer, because in 20 years it has almost 30 to 35 meters fall. There is a decline in, let us say. So at the same point, shallow aquifer is, by seeing the shallow aquifer, one can say, in our area, water levels are very shallow. In well, we can visible, water level is visible. Why to bother about our, why you are saying you are drawing more water, but water level is visible. But the deep water level, which is not at all visible for you people in a common man, but only through the scientific studies only we can understand. Because of this, people are not drawing the top aquifer, only people are drawing the deeper aquifers, which is costing, they may be getting good yields, but it is costing power consumption as well as we are disturbing balance. And you see the same hydrograph with rainfall, though there is a good rainfall, little bit, water level is a little bit rising. Again, because of the rainfall is more, let us say increase our area, crop area. That's why people are drilling more and more wells. And again, little bit, whatever the things it is observed for every year, again it has fallen. There is a song, fallen, something like that. It is only fallen. It's only falling condition. How much it's, you see the rainfall, this is up to 300 mm, 400 mm, 500 mm also there one day. But even then, water level is not increasing because so much stress on these deeper aquifers. So these are the drop in piezometric heads. What are the remedies? only for the phreatic aquifer, artificial recharge structure, even deep also recharge structures. The phreatic aquifers were to go for the whatever the existing tanks, desilting, and the deeper aquifers. We have to recharge the, if you recharge the top aquifer, because of our confining layers in between the shale layers or clayey layers, thick, huge thick, up to 10 to 20 meters thick clay layers are there. That clay layer is not allowing the top water to percolate downward. That's why water levels are deepening. That's why for that we have to design in a different way, recharging the deeper aquifers. So for that we have to go for the some other system like recharge shaft. We have to drill a well. That is for recharging purpose. Just we have to leave that open slot up to the top of the cleared zone, means evacuated zone. Then whether the whatever we send the water, well, it accommodate that water. Yes, there is a sufficient based on this fall of the initial and present water levels. That much space is available, aquifer space. So we have calculated the aquifer space mandal wise for all the districts of sandstone falling area and calculated overall. In this area, shallow aquifer can accommodate 54 MCM of water for storage, whereas deeper aquifer, you see how multiplied 3 times, almost 4 times. 195 MCM can accommodate our recharge water. So there is a scope for recharging the deeper aquifers, to some extent shallow aquifers. So for this, we made a plan and we have submitted. These are the recharge shafts. We have to be very cautious while constructing the simply drill a well and leave a slaughter pipe and leave it. No, there is a science is involved behind that. Scientifically, we have to construct the recharge shaft. So this is a project was prepared based on these studies. So benefit to the recharge is 234 MCM after constructing of so many tanks and recharge shafts. It's so overall the outcome of this project will be, if you implement artificial recharge, water levels will increase. Once the water level increase, water well sustainability will increase, and power crisis, you can come across that power crisis, and irrigation potential also increase. The present groundwater development stage of groundwater development is presently 58. We can bring little bit down, that is 46%. It's good to come out of this. So now the problem comes from where we have to get the water. This Polavaram canal is coming. So from that Polavaram canal, for Polavaram such a huge project, to have that so much, it's about 400 to 500 MCM is not much matters. So we can take the water from the Polavaram as well as up till then the rainwater we can harvest. Now let us come to the third part, southernmost part of the alluvium. Sir, am I running in right time?
15 more minutes. 15. Now it is quarterless one.
So I have 10 more minutes.
Yes, sir.
Yes.
Anyway, third formation.
Yes, sir.
This is alluvium. So alluvium is nothing. Simple loose formation. There will not be much problems. Am I right? Yes. Myself will say yes. Not much problem. Because these are all highly porous. Aquifer properties are very good. As our earlier speaker mentioned, T and other things, so many things you'll have the compared to other formation. In this formation, you'll have the higher values. So groundwater point of view, these are good aquifers, quantity wise. Since it is a formation, environmental deposition is in marine environment. If you observe, this is the coastal alluvium and it's a deltaic alluvium. If you extend this line, the earlier coastline was here. If time permits, I'll show the previous trend lines also. Earlier it was here. Like that, 4 or 5 trend lines we observed. and this present coast is here. So earlier first trend line, if you draw here, that is a 4,500 years BP. That is the first trend line, 4,000 years BP, and in between 3,000 and 2,500 to 1,500, and the last thing is latest one is 1,500 BP, 1,500 years BP, and the present coast and the last observed coast is 1,500 years gap is there. BP means before present. Since it is an environment, depositional environment, deposition from where it has come, the river, and this river while flowing over this deltaic area, it has left so many paleochannels and so many geomorphological features. For phreatic aquifer, they are helping a lot to have to maintain the quality as well as the quantity also. In first slide, we observed the drainage pattern. In northern part, it is there. In mid part, it is there. When it comes to the deltaic area, no drainage, other than the major drainage of the river. What happened to the drainage? Where it went? So it is as soon as the rainfall falls, it comes to the alluvium terrain and it percolates downwards and it is flushing the phreatic aquifer. So all the time phreatic aquifer is fresh. Even our studies also reveal that phreatic aquifer, that is top aquifer, quality is fresh except at places all along the coast, particularly where the aquifer system, aquaculture is the culprit to deteriorate the water quality. So if you observe the alluvium terrain, Balavaram is nothing but it's a eastern part of around 20 kilometers east of your university, and Punyakshetram is a further 10 to 15 kilometers, I think towards Kakinada, south. Here the alluvium starts. This entire is alluvium. If you see the sandstone Rajahmundry formations paleotopography, up to here, up to Peddada, from there it has come to Peddagadi Moga. There is a sudden fall in this. This is nothing but like a continental shelf, general scenario of the continental shelf. So there is a huge thick of alluvium. Even at places, this sandstone is rarely occurring at a shallow depth, up to 200 to 300 meters. Some places we observed, and the rest of the area beyond 600 meters also, there is no alluvium because of this continental cliff, and there are structural disturbances. Now, based on NACTUM studies and based on the lithological logs, and it depends upon the need-based well constructions, in this area, 5 aquifers have been identified. This is a top aquifer, then followed by unconfined, that is an aquiclude, that's a clay, then again sandy layer, then clay, sandy layer, like that, up to 300 meters, we identified 5 aquifers. This is 1, 2, 3, 4, and 5. Clearly, majority of the area, these aquifers are being separated with aquiclude. So clearly we can say this is not a single aquifer, it's a multi-aquifer system exists in alluvial terrain. Simply we can say entire is alluvium, why to separate it? But being a scientific way, we have to separate and we have to study each aquifer, how it behaves and what was its environment and how it will be useful in a future. Like that, there are cross sections and fence diagrams. If you see here in the center at Dangeru, clear-cut huge thickness of the first confining layer. That's why this phreatic aquifer, this unconfined aquifer, not being disturbed by the deeper aquifers even at the time of pumping also, so that there is no cone of impression because of the pumping by saline water. Deeper aquifers are saline because it's all the time deposited in marine environment, whereas the top aquifer, it's not much marine environment. Even now, though it is a partially marine environment, but it is being flushed away because of the rainfall which is coming up the side. And how we identified the different aquifers? You are saying confidently 5 aquifers. Somebody may ask, what is your background? This is the things, geophysical logs, lithology, geophysical logs helps a lot in differentiating the aquifer system. Again, it's the SUT, and there are 3-4 different scenarios in deltaic area. Top is fresh, followed by saline. The entire area is saline. What is the top is fresh? This log clearly shows geophysical log SUT is developed up to 60 to 70 meters. And then there is no SUT, but SPS developed. That means this formation yielding a water and it is having the good potential zones, but the quality is increased. That's why because of the quality salinity increase, SUT will not develop. If you say there is no SUT, that means formation is not yielding any water. Yes, it is yielding because of it is SPS developed a lot. So that means geophysical log helps a lot for you in demarcating and differentiating the aquifer to aquifer and identifying the quality point of view. If in this case you see there is no SPS developed, but SUT is very nothing. It's almost flat line. But at the shallow aquifer, there is a SUT development. SP is positive. That means good quality of water. Whereas in this case, all along at some places along the river, where the meandering occurring, there is at Rahul Palam. Yes, am I right? Yes, it is Rahul Palam. There, because of the river activity, there is a huge report of coarse material, and the quality of the water at this zone is fresh. This is along the river course. So based on these logs, we can say easily the quality top is it's about 5,000 to 6,000 EC, and bottom is it's about 10,000 to 15,000 EC. Do you know what is the quality of this? It's only 1,400. Rahul Pala, this is only 1,400. It's a finding that these are the things NACUM studies reveals. These are the findings. So we should not leave any part in our studies like geology, geophysics, geochemistry, as our professor earlier Professor Jagannath Ragar mentioned. These are integrated studies. We have to clump up all the things, environment. Also, we have to study how it has formed. These are all the things. These are the pumping tests we conduct, as earlier mentioned, to understand quality, quantity, whether it will sustain to our yields and to understand the parameters. And this is our cluster well where we identified the 4 aquifers by drilling the 4 + 4, 8 wells. I conducted the 3 wells, and you see these are so many observations. 1, 2, 3, 4, 5, and here within a well there are 3 piezometers. That means 4 aquifers. 1 is unconfined and 3 confined aquifers. Pumping test carried out based on these. Like this, there are number of well fields are there. All these because of these activities, we could identify there are 5 aquifer system of having the 5 aquifers, multi-aquifer system, and which is the top aquifer is saline and deeper aquifers are invariably saline and yielding good quality. So if you come to particularly this section, top is unconfined, there is a confined layer, confined. Now let us see the quality variation. Are you able to read the EC values? If not, just I will say top aquifer is the EC is 540 to 1700. This at 4 places we have conducted the pumping test. In the second aquifer, EC is 3000 to 5600, EC varying. And the third aquifer, that is a second confined aquifer, is having the water level is very shallow. This first aquifer is having the water level of 3 to 4 meters. Second aquifer is less than 2 meters. First aquifer is almost 1 to 1.5 meters, whereas the EC is increasing 500 to 20,000. So deeper aquifers are very saline. Quality is inferior, quantity is increasing, and while pumping the top aquifer, the free bottom aquifers are not contributing anything. That we have proved by our pumping test. So overall, after these studies, so this is the aquifer disposition we identified. First unconfined is fresh, confined is its varying thickness from 20 to 60 meters is brackish to saline. At places it is brackish also there, and deeper aquifers are invariably saline. Quantity is good, discharge is good, T is good, S also based on S also you can say it is a confining or unconfined conditions. And quality point of view, phreatic is good and deeper aquifers are invariably saline. Whenever there is a sandstone formation occurrence in our studies at Kakinada, at the depth of 75 meters, we encounter tertiary formation, that is of fragmentary sandstone, which has yielded 500 meters, 500 EC. It's a good achievement. Top is it's up to 6 to 7,000 EC. At the depth of 80 meters to 120 meters, there is a fragmentary formation that has yielded good quality of water. So this is the variation of at one place. Deeper aquifer is 18,000, 5,000 is middle aquifer, shallow aquifer is it's about 500. So what are the problems in this area? Let us finish up fast. There is a groundwater salinity, seawater intrusion, salinity pre to post, so much variation is there. Post monsoon it is reduced salinity, and seawater intrusion also not much intrusion. Up to it is limited to the 1 kilometer only with during and pre and post also. And whereas the western part, there is in West Godavari, in pre-monsoon up to 24 kilometers it has come seawater intrusion. But whereas in East Godavari, that problem is not much. This aquaculture is creating a problem. It is making an havoc. Existing irrigation fields are being converted into the aquaculture. Because of this aquaculture, these adjacent fields, because they will construct high bunds, because of the leakage through these bunds and storage of the breakage to saline water, these adjacent fields also getting spoiled because of the waterlogging as well as the quality contamination. And you see the pesticides and things others that you are using the aquaculture, and it is spoiled the groundwater quality also, phreatic aquifer. So we have to restrict the aquaculture near to the coast only. This is the waterlogging because 90% of the area is being irrigated by the groundwater only. In the earlier sandstone, it is 70% is groundwater, whereas here 90% is surface water. This is creating a problem of the waterlogging. So for this, what is the remedy? In the project area, upland area, there is a groundwater availability is there. That you have to allow the farmers to pump that water from the groundwater and utilize for the irrigation. So for tile unders, you have to leave that water for the tile unders so that the logging problem we can reduce. So like that, there are majorly 4 aquifers, major discussing the management plans, each is having the, because of the time constraint, I am not going in detail. So at the end, we have to study the water below the water we have to study, then only we can understand aquifer very clearly. Thank you. Any else? Hope I am in time.
Yes, sir. You're in time. If you any students or scholars or faculty, if you have any questions regarding, you can please ask now.
Krishna garu.
Namaste, sir. Professor.
Namaste. Professor Venkateswara.
Sir.
Just a few words. First of all, thank you. It's a very nice lecture.
Thank you, sir.
It is not a theoretical lecture. It is the information gathered by from your studies, and the identification of the aquifers and the plans that are being made for the artificial recharge is very good.
Thank you, sir.
So regarding this, I would like to add some points to this. Later we can discuss in detail.
Sure, sir. Sure, sir. Thank you, sir.
So, I have a lot of experience in this.
Yes, sir.
East Godavari area.
Yes, sir.
First of all, it is a very apt that we have chosen, that the government has chosen the East Godavari district, because it has all sorts of topography. That is the hilly terrain, uplands, and the delta, and at the same time the different rocks, hard rocks, soft rocks, alluvium, and at the same time we have multi-level aquifers and also the seawater intrusion.
Yes,
so all sorts of advantages, disadvantages, everything is there. So it's the best model for the study of the aquifers in the system. Now, regarding this, you might have collected the information like the majorly in the deltaic region, there's a huge paleo river system.
Yes.
Actually earlier we did a groundwater investigation very quickly for 72 villages in the East Godavari, when the barrage was breached, there is no water in the coastal area, groundwater, drinking water in the coastal area. So for that, Professor Vaidyanathan has given us the aerial photography map, the paleo channels identified from the aerial photographs. So we have overlaid this on the topo sheet, and with that map, we could able to find out directly go to that paleo channel area near to the village, and doing the electrical survey, we could able to trace out the freshwater aquifer. That is because you know that the resistivity variation is very high between saline water and fresh water. So within a day, we could able to identify the source for groundwater, at least for drinking purpose. That's why. So the distribution of the paleo river systems. Paleo river systems also at different levels. We have mentioned that multi-equivalent system, even up to 300 meters, the sand is continuing. With the interval of the clay sand like that. On the shallow, now you can find within 8 to 10 meters, you will find a huge amount of the paleo river system, aquifer system. So it is being tapped now with the shallow bore wells, and the yields also like a 40,000, 50,000 liters per hour, like that. So these are also getting the saline because of the maybe over exploitation and also the aquaculture due to that. So now at a 20-meter stage, there is another big system of paleo channel system. There is also fresh water is there. So now we can, what my suggestion is, you are suggesting about the recharging the aquifers, making a deep shafts like that. So in the hard rock terrain, it's okay, no problem. In the paleo channel area, by locating this, exactly demarcating these paleo channels, which are very shallow, within a 10 meters. So we have to, there's already canal system is there. Using that canal system, we can use that because about 8 to 10 months, so the water will be there in the canal system. Using that water, we can charge these shallow aquifers. Because, you might have noticed also that during the summer season, the yields will get down so much in the shallow aquifers. And again, immediately after the flows in the river course, existing river course, you will find they get charged directly. Because the river being the main pipeline, and the paleo channels being the sublines connected to this river course. So that's why immediately they get charged in this one. So that's why what I suggest is the recharging in the alluvial area, particularly, you utilize the existing canal system, because canal system also consists of, particularly if you leave out in the rainy season, other time it will be a clear water. So that water can be used for the recharging these shallow aquifers by means of a shallow recharge wells, or that type you can use it. So that's my suggestion regarding the recharge of this one. And the deep in the in the upland areas, particularly sandstone areas. So I recently I visited that areas. There consist of so many open wells are there. All got dried up. Some are closed like that. So in these areas, because earlier they used to get groundwater through the open wells. Now, because of the over exploitation, the groundwater has gone. They are going up to 400, 500, 600 feet also, exploring the groundwater. So these open wells also can be utilized as the recharge wells, recharge the aquifer system, because already existing open wells are there in the farmers like that. They can be encouraged to recharge these wells if you supply the, there's a canal system existing through Polavaram or coming like that. So these areas also can be encouraged using that open wells. So that's a thing is that, but you are carrying out very good studies in identifying the aquifer system, and also we can detailedly can also discuss with you about what can be done regarding the artificial recharge and everything.
Sure.
So that's what I want to say. Thank you for giving me the opportunity.
Thank you, sir. Regarding the paleo channels, if you given time 1 minute, I'll show what is actually still that studies are going on. Two, fine. Just one slide I'll show, and within 2 minutes I'll finish up it.
You might have, taken that earlier also. In detail,
Yeah.
1:50,000 scale, the mapping was done.
Yes, sir.
So you can utilize those maps also. I do not know whether you have acquired them or not.
No, here what the reason for the paleo channels wells getting salinized or quality deterioration during summer and reducing the yields are the reasons. These blue spots are our observation wells where we drilled the wells. When I studied these wells, the paleo channels which are isolating, they are getting the dried up or reduced in the yields and the quality deteriorating during summer. Whereas if you observe this well, this paleo channel, because all surrounded by the paleo well is surrounded by the paleo channel or within this, there is a continuity supply of the through river, and that's why it is even during summer also this well is yielding good water and water levels are not reducing. So like this, there is a detailed study is required, sir. Anyway, definitely I'll follow up your instructions. I'll have the personal day.
What I have observed is, along that main river, Godavari River,
yes,
up to 40 kilometers, the Teki, Kola, that places, during summer they get brackish water because the river course consists of the backwaters at that time.
Yes, sir.
So during that time they get brackish. Again,
Yes,
when the rain comes, again they become fresh water. So that influence will be there because of overexploiting groundwater in those areas also. Because the backwater comes about 40 to 50 kilometers, even up to that highway, about 7 to 8 kilometers down of highway, the backwaters are coming.
Oh.
So that influence will be there. But
Anyway,
that
I'll
we
incorporate.
now that we can thing. But only thing is that you can suggest that what that could be done for the
Sure, sir. I'll discuss with you in person, sir. Thank you.
Okay. Thank you for giving the opportunity.
Thank you, sir.
Thank you, sir. Thank you very much, Professor Venkateswara sir, for your insights and suggestions for this study. Now, before we close this session, we would like to hear how this program went. Yes, madam.
I would like to
Yes,
ask. Actually, no questions, but I would like to say something. I hope all the participants are enlightened on various aspects of aquifer and groundwater mapping discussed in the webinar. And I would like to thank all the speakers and regional director for their time and sharing their knowledge on different concepts of groundwater and aquifer mapping. And I also take this opportunity to humbly request G. Krishnamurthy sir to establish or see the possibility to establish a piezometers and related equipment in and around Adikavinani University to continuously monitor the groundwater levels.
That proposal is already within the campus.
Sir, pre and post monsoon.
The survey had already been completed.
Okay.
Within our campus, they proposed already a piezometer in main campus as well as in the Kakinada campus also.
Okay, but I never seen that the documents. That's why I asked. And this also help in getting the valuable data in the groundwater scenarios to help the students, sir. And also, I request, in addition to that, I request Krishnamurthy sir to see the possibility of jointly undertaking or collaborating with the Adikavinani University for groundwater and aquifer mapping projects, sir, especially in East Godavari district and surrounding regions. And last but not least, it would be a great help to see the Central Groundwater Board takes our final year students for internship programs, sir.
Okay, madam. If you are sending, definitely we will allow them to internship course also. Now that nearby only Prakasam district, now Krishna and nearer districts only. If possible, we will see the constructing piezometers as you suggested to monitoring the groundwater levels. That also we will see, madam, in future.
That is a big procedure for getting the internship to the students. It would be better to make it easy, sir.
The procedure from head of the department, you can write a regional director
I'm writing the
for
letters and
requesting the internship, and we will train them and we will sending back, madam. Actually, you can send, no problem.
okay. Thank you. Thank you.
Madam, 1 minute, madam. Just wish to express. Yes, yeah. Good afternoon, sir. Krishnamurthy, sir. Actually, regarding this activities and then data available in the consent, whatever the explanations and then whatever the presentation given by the Krishna Garu is a very beautiful and very extensive scientific presentation he made. And then another important thing is whatever the 2D and presentations. What I feel that what are the levels of the scaling of the study related to the just we came to know that there are two aquifers are going to be monitored in Rajahmundry sandstone. One is shallow and then one is deeper aquifer. So shallow concerned, if the data is available, see as far as the present Rajahmundry in and around Rajahmundry, upland of the Rajahmundry, we see that most of the wells are deeper aquifers, piezometers are existing. If the data related to the shallow aquifers and then deeper aquifers is available to the students as well as to the academicians, then there is a possibility of further linkages, whatever the gaps they are existing in the this mapping system. If the gaps are known to the academicians and researchers.
Ravi, please comment on this issue.
Then we will try to think of to fulfill the gaps and mapping system. This is another important thing is actually from the 2007 onwards, I have been involved in this type of activities starting from Tirupati, and then I had given a lecture in Tirupati also related to aquifer mapping in 2014, and then we conducted in 2014 also in the university. Listened to this same workshop. That was within the campus, we made it. So what my wish is, if we are going to coordinate with the, as Madam suggested, having data collection and data monitoring and then data linkages, if there is any possibility, so that the research scholars as well as to the researchers will be focusing on in detailed studies. Thank you very much. Thank you, sir.
And also, sir, in addition to that, sir, we can get that aquifer mapping of micro level, like Adikavanana University campus, in and around the region, surrounding region. Micro level aquifer mapping data.
Ravi, please.
Yes, madam. Yes, madam.
Comment on this.
Micro level aquifer mapping studies we can take up, madam. That's not a problem. The existing data available data, we can also do a micro level aquifer mapping in and around Adikavanana University with the collaboration of students and faculty.
Okay.
That can be taken up.
Okay.
We'll discuss about these things offline also.
Offline.
Now we'll
okay.
Time now to conclude this
Sir, I have a
question.
question. So please.
Yes, sir.
Yes, sir.
Go ahead.
Sir. Yes, sir. Krishna, sir. Yes. Is it audible? Yes, sir.
You go
Yes.
ahead.
Please.
Yes, sir. Actually, you just compared that water level data and rainfall. What is the reference height for that?
Pardon?
You compared that water level
Okay.
and rainfall data. And
Okay.
what is the reference height for that?
RL.
Reference height, sir. Reference height. So whether you are
that-
taking the height, reference height, what is that?
That is the point is above mean sea level.
Above mean sea level. So if
That-
I have a GPS site in that, so can I correlate directly with that?
Directly?
Yes, sir. Can I compare with that? Means can I compare that water level data with GPS site?
Yes.
Yes, sir.
No. Actually, that is a point, observation point. GPS you will get that the so many meters above ground level. From there, it is from that point, the water level reference is below that we have to convert into the reference to the MSL. That is a piezometric head we have to convert. This is only from the top surface to the water availability.
So you are telling that MSL level and MSL level, yes, sir.
That point is that our observation measuring point is reference to the MSL.
Okay, actually, recently I am doing some research in urban areas.
Okay.
For especially groundwater depletion rate.
Okay.
Actually, I observed some depletions, groundwater depletion. So I got a subsidence in some particular area. So how can I correlate with this water level data and this whatever my GNSS data and remote sensing also? I'm incorporating some remote sensing technique also in that. So how can I correlate? So that's what my doubt.
So particularly you mean to say there is a land subsidence?
Yes, sir. Yes, sir. Please.
Are you talking about land subsidence or what?
Yes, sir. Yes, sir. Land subsidence. Sir. That is the vertical land subsidence. If due to the groundwater depletions.
Land subsidence due to
the water
extraction.
Yes.
Okay.
Yes.
May I know what is the area? Which area you are referring?
The Gujarat, sir. Gujarat.
Gujarat. Which part of Gujarat?
The Kutch region.
Kutch is sandstone formation. Actually, that is the Kutch area is the. There is a number of times it is a land subsidence and upliftment taking place.
Actually, I'm telling that actually not in whole Kutch. I'm talking about only urban regions because urban area only the groundwater depletion rate very high. So I'm not talking about all the area.
Really speaking, if you see observe the aquifer properties and the aquifer material properties in urban areas, land substance because of the over exploitation of the groundwater. Maybe it's personal opinion, may not be.
Yes, sir. Actually, I'm facing the.
Anyway, you're referring to Gujarat. Which part of the Gujarat you are referring?
Actually, I'm Kutch region.
Kutch region. Which city?
Bhuj.
Which proper Bhuj is sitting on the compact sandstones. So there is no chance of the groundwater subsidence because of the over exploitation. There the water levels are 20 to 30 meters only, and they're also having the good yield. So proper Bhuj is not because of the substance, not due to the over exploitation of the water. That is, there is a tectonic activity.
I'm removing the tectonic activity. Sorry.
Yeah.
I'm removing the tectonic activity. Then I got some subsidence levels. So how can you remove that?
That may be the temporary phenomenon, maybe that groundwater fluctuation. Maybe
the. I removed the tectonic activity. I removed the seasonal variation.
Sorry, Babu, sir.
Anyway, that is a time constraint. Let us have a talk.
We are going little offline. It seems. If you want the mobile number of Krishna sir, I will share you can anyway time contact that with us. You can contact to SU office or CW Southern Asia office. We will
okay, sir. Okay.
Provide the mobile number also to the Gujarat office. Please, you can note down. Krishna sir, can you please share if you want further discussion, or you can contact us also.
Yes.
Right now, because if we are going ahead of this thing, almost half an hour we.
Yes, sir. Actually, I'm waiting for that question.
Yes. So, madam has shared the link of feedback in the chat box. Kindly request you to kindly fill how the program went for you. And for today's program, we have had a lot of support from various quarters. And when we contacted Aditya University Rajmahendravaram, the Honorable Vice Chancellor had readily agreed to conduct this PAP with the students and faculty and research scholars. And he has readily agreed to come and grace the occasion as a chief guest of this program. And he came today despite of his busy schedule. And we are very much thankful to him for his gracing the occasion as well as motivation speech and encouraging the students. And we are very much thankful to Professor Ashok sir, Registrar, and Professor Ramaneshwari, Principal, for their support. And particularly, we are very, very much thankful to the support and overall coordination and convening the program provided by Professor Nukaratnam Garu, Head of the Department of Geology, Aditya University. Right from planning to implementation, she coordinated the entire program, making us very, very comfortable and technically also. Instead of Google Meet, she given us the Zoom link for all the support right from the beginning to the end. We are very much thankful to Professor Nukaratnam Madam, Head of the Department Geology. Thank you. We are thankful to G. Krishnamurthy sir, Regional Editor in Charge, and the speakers of the program, Srimati Caroline Louise and Dr. V.S.R. Krishna, Officer in Charge, Unit Office, Visakhapatnam, and Dr. Anantarao, Assistant Hydrogeologist, SU Visakhapatnam, for this on-ground support and coordinating at the university. And finally, to all the students and research scholars, faculty of Aditya University, and my colleagues and Central Groundwater Board for their valuable support. With this, we'd like to we'd like to conclude this program. Thank you one and all for making this program successful. We'll meet again. And those have any doubts regarding this, or if you want further discussions regarding anything, just like in the Gujarat case, if you can approach you as well. And Madam, as you are requesting, definitely will come to you regarding this matter of establishing epigenometers and micro-aquifer mapping studies in Aditya University. Definitely, sure. Thank you, Madam. Thank you one and all. Thank you for this program.